Hello students, today we will start a new chapter, chemical kinetics. Before going to start this chapter, I want to ask some questions. Can you say in atmosphere both nitrogen and hydrogen are present but they do not react with each other? But you will find in Haber's process nitrogen reacts with hydrogen when the pressure is around 150 to 200 atmospheric pressure. Temperature lies between 400 to 500 degrees Celsius, and in presence of iron catalyst the reaction gets faster. Why? Carbon dioxide in atmosphere does not react with water vapor, but in presence of sunlight and chlorophyll, green plants prepare their own food, that is carbohydrate type of foods, from carbon dioxide and water. Why? The answer of all these questions can be explained by chemical kinetics. So just recall, in class 11 there was a chapter thermodynamics. Thermodynamics explains the feasibility of a reaction. What does feasibility mean? Whether the reaction will take place or not, that is known as feasibility. That is explained by thermodynamics. If delta G value becomes negative, then the reaction gets feasible. Next is chemical equilibrium. What does chemical equilibrium explain? Chemical equilibrium explains to which direction the reaction will take place. The reaction will take place in forward direction or the reaction will take place in backward direction. That is explained by what? Chemical equilibrium. Next is about this chapter, chemical kinetics. What is chemical kinetics? It is the branch of chemistry which deals with the rate of a chemical reaction, mechanism of a chemical reaction, and conditions necessary for a chemical reaction to occur. ठीक है? So what is rate? Rate means the speed with which the reaction takes place. What are the condition means? Condition means what are the catalyst necessary, what is the temperature necessary, what is the pressure necessary, and whether sunlight is necessary or not. All these come under conditions of reaction. Remember, kinetics comes from a Greek word kinesis. Kinesis means movement. ठीक है? So next we will discuss different types of chemical reactions. What are the different types of chemical reactions? First is very fast reaction, next is very slow reaction, next is moderately slow reactions. Very fast reaction example is precipitation of silver chloride when aqueous solution of silver nitrate reacts with aqueous solution of sodium chloride. I think you have conducted this experiment in class 10 in your laboratory. You will take aqueous silver nitrate solution and you will mix aqueous sodium chloride solution with it, and you will find instantly white color precipitate of silver chloride. That is very fast reaction. Next is very slow reaction. Rusting of iron or corrosion of iron is a very slow reaction. It takes months to take place. Next is moderately slow reaction. In chemical kinetics, we will specially deal with this type of chemical reactions. So first example is hydrolysis of ester. You know, when ester undergoes hydrolysis, it forms carboxylic acid and alcohol. Next is reaction of nitric oxide with oxygen to form nitrogen dioxide. Rate of a chemical reaction. What does it mean? Rate means speed with which the reaction takes place. So let's take an example. Suppose 1 mole of reactant reacts to form 1 mole of products. That means at time t is equal to 0, the amount of R is 1 mole. Then what will happen? It will go on reacting, and finally what will happen? 1 mole of product will be formed. That means the concentration of reactant will gradually decrease and concentration of product will gradually increase with passage of time. Let's think about, suppose at time t1 concentration of reactant is R1 and at that time concentration of product is P1. Similarly, at time t2 suppose the concentration of reactant is R2 and concentration of product is P2. Then what is the change in concentration of reactants? Initially it was R1 and finally it is R2. Then change is how much? Change is concentration of R2 minus concentration of R1, that is delta R. Similarly, what is the change in concentration of products? That is P2 minus P1, that is equal to delta P. So this change in concentration took place in how much amount of time? That is T2 minus T1, that is equal to delta T. So right now let's find out the rate of disappearance of R. Why? Because the concentration of R gradually decreases. So here you can see the minus sign is given. So rate of disappearance of R is equal to, what is the change in concentration of reactant? That is delta R. In what time? In delta T time. So as it decreases, so minus delta R by delta T. Similarly, rate of appearance of a product, how much? It is plus, because the concentration of a product increases with passage of time. So it is plus delta P by delta T. Okay? So next, let's take an example. PCl5 undergoes decomposition to form PCl3 plus Cl2. That means phosphorus pentachloride reacts, that is decomposes to form phosphorus trichloride with chlorine. So what is the rate of a reaction? So rate of the reaction is minus. Minus why? Because this is PCl5. PCl5 is reactant and the concentration of reactant decreases with passage of time. So it is minus change in concentration of PCl5, that is delta PCl5 concentration divided by delta T is equal to plus delta concentration of PCl3 by delta T is equal to how much? Delta concentration of Cl2 divided by delta T. Okay? So another thing you have to remember, if there is small change in concentration, then we will not write delta, rather we will replace it by small d. So d concentration of PCl by dt, right? That like that we will write, we will discuss in later situations. Units of rate of a reaction. What is the unit of a rate of a reaction? That is concentration time inverse. If concentration is expressed in moles per liter, so in which case we express in terms of moles per liter? If the reaction is in liquid phase, then, or that is a solution, then the unit of rate will be moles liter inverse second inverse. Why? Because the concentration is moles per liter, so that is mole liter inverse. Okay? So next is, if the reaction is carried out in a gaseous phase, then there we take atmosphere, so the unit of rate will be atmosphere second inverse. Next we will determine from a graph average rate of a reaction and instantaneous rate of a reaction. So how will we determine average rate of a chemical reaction? So rate of appearance of reactants are average. This is average rate of reaction is equal to minus delta change in concentration of R divided by change in concentration of T. Similarly, for disappearance of product, it becomes plus delta concentration of P divided by delta T. So let's plot the graph for these reactants. we know with passage of time the concentration of reactant decreases. So at time t is equal to 0, concentration was maximum, and with passage of time it gradually decreases. So here we will do what? We'll take the rate, we will find out the rate between T1 to T2. Then how will we find out the average rate of a reaction? Suppose this is time T1. Then what we will do? We will plot a parallel to the y-axis to the curve. So we are taking a parallel. This should be parallel to this, and it will intersect at some point. Then we will draw a perpendicular to y-axis. So this is T1, and here we are getting what? Here we are getting R1. Here we are getting R1. Similarly, this is time T2. From this we will draw a parallel line to the y-axis. It will intersect at some point. From this we will draw a perpendicular to y-axis. This will give you R2. So R2 minus R1 gives you what? Delta concentration of R. So you got delta concentration of R, you got delta T, and there you can write minus delta R by delta T. Similarly, if you take the case of products, how will you determine? Suppose this is time T1 and this is time T2. Within this time, it is asked to find out the rate. Then how will you find out? You will draw a parallel to y-axis from this T1 up to the curve. Then you will draw a perpendicular to y-axis. Similarly here, from T2, you will draw a parallel to this y-axis up to this curve. Then you will draw a perpendicular to y-axis. Here you will get what? P2. Here you have got P1, concentration of P1, concentration of P2. Then what you will do? Concentration of P2 minus P1 will give you delta concentration of P. Then you will put the value. This is delta P, this is delta T. So you put it here. You will get average rate of chemical reaction. Next is, how will you determine instantaneous rate of reaction? So the difference between these two is average rate of a chemical reaction is taken over a longer time duration, but instantaneous means at a particular time. So R instantaneous is D concentration of R by dt, that is minus D concentration of R by dt is equal to D concentration of R by, this is product, D concentration of P by dt. Got it? So how will we determine here? So you see, we have taken here the reactant curve. So this is the reactant curve. It goes on decreasing. Suppose it is asked at t seconds, what is the instantaneous rate of reaction? So how will we determine? We will draw a tangent to this curve. We will draw a tangent to this curve. Then what will happen? Suppose we have drawn a tangent of this much length here. Clear? Next, what will happen? We will draw a parallel to this. We will draw a parallel line to y-axis, and from here we will draw a parallel line to the x-axis. They will intersect at some point. This will give the value of dr. This will give you the value of dt. Then what will be R instantaneous, that is instantaneous rate of reaction, minus D concentration of R by dt. You find out. So there is another way to determine instantaneous rate of reaction from this angle. So how? You see here, you have to complete this triangle as usual, as you have done in the previous case. Then what you will do? You have to extend it. Why? Because you have to determine the angle made with a positive x-axis, and this side represents your positive x-axis. So you will take this angle. Okay? Suppose if you have taken this as theta, so what it will be? It will be 180 minus theta. Then what you will do? You will take tan 180 minus theta. That gives your instantaneous rate of reaction for reactants. But in case of products, the situation will be slightly different. You see here, suppose at this point you are going to find out what? You are going to find out the instantaneous rate of reaction. Then what you will do? You will take the tangent. Then what you will do? You have to complete this triangle. This gives the value of dp. This gives the value of dt. So you can see what is instantaneous rate of reaction formula? D concentration of P by dt. So you got in this manner. But the important part is tan theta. That formula, in that formula, how will we determine instantaneous rate of reaction? So you see here, we have completed this triangle. Then which one will be theta? You see here, this will be theta. Why? Because we have to take the angle made with positive x-axis. So you see, this side represents positive x-axis. So you have to take this angle here. Then we have to take tan theta. Then we will get the tan theta means what? Tan theta means instantaneous rate of reaction. But in case of reactants, we are taking this side. In case of products, we are taking this side. We have to remember the basic thing is that we have to take the angle made with a positive x-axis. That's the thing. Next is mathematical expression for rate of reaction. So what is the mathematical expression for rate of a reaction? If this is divided into two parts. If stoichiometric coefficients for reactants and products are same, suppose you find out here PCl5 undergoes decomposition to form PCl3 plus Cl2. Here the stoichiometric coefficient is 1, here it is also 1, here it is also 1. So stoichiometric coefficient in reactants and products both are same. Then how will we find out the rate of a reaction? And if the stoichiometric coefficient of reactants and products are not same, suppose in this case dinitrogen pentoxide stoichiometric coefficient is 2. Here it is nitrogen dioxide stoichiometric coefficient is 4. In oxygen it is 1. Here the stoichiometric coefficients of reactants and products both are different. Then how will we determine the rate of a reaction? So let's discuss here. Here rate is equal to minus. Minus, remember this is for reactants because the concentration of reactants decreases. So minus delta concentration of PCl5 by delta T is equal to plus delta concentration of PCl3 by delta T is equal to plus delta concentration of Cl2 by delta T. Clear? If the stoichiometric coefficient is different, then what we will do? We will divide that stoichiometric coefficient. That's the difference only. So here the rate is what? This is reactant side, so minus. Here 2 is there, so we have to divide by 2. So half delta concentration of N2O5 divided by delta T is equal to plus y, because it is product side, the concentration will increase. So plus 1 by 4. Here 4 is coefficient, so we have to divide it by 4. 1 by 4 delta concentration of NO2 by delta T is equal to plus delta concentration of oxygen divided by delta T. That's the thing. So let's take another example. I think you can do it also. 5Br minus plus BrO3 minus plus 6H plus gives rise to 3Br2 plus 3H2O. So here the rate is minus 1 by 5, and this is the term change in concentration of bromide ion divided by delta T. So that's the thing. Okay? So minus delta, here stoichiometric coefficient is 1. So minus delta BrO3 minus concentration by delta T, that is equal to minus, here the stoichiometric coefficient is 6. So 1 by 6 delta concentration of H plus by delta T is equal to stoichiometric coefficient is 3 and it is in product side. So it will be plus. So it is plus 1 by 3 concentration of delta Br2 divided by delta T is equal to, here the stoichiometric coefficient is 3. So 1 by 3 delta concentration of water divided by delta T. That's the thing. Next is the factors influencing rate of a chemical reaction. What are the factors that they influence the rate of the reaction? For example, concentration of the reactants. You know, in class 11 there was a Le-Chatelier's principle that explains that if the concentration of reactants is more, then the reaction gets faster and more amount of products is formed. So the reaction occurs at faster rate if the concentration of reactant increases. Clear? Next is temperature. More is the temperature, greater is the rate of a reaction. So in the latter part of this chapter we will discuss how temperature plays a very crucial role in determining the rate of a chemical reaction. Most of the chemical reactions, it has been found that the rate of a chemical reaction approximately doubles by every rise of 10 degrees Celsius. That we will discuss later on. So next is catalyst. Catalyst, what is catalyst? Catalyst is a substance which do not undergo chemical change or do not gets consumed in a chemical reaction, and that enhances the rate of a reaction. That means it helps to attain the equilibrium quickly. That will increase the rate of a forward reaction, and it will also simultaneously increase the rate of a backward reaction, as a result of which the equilibrium will be attained quickly. So there are different types of a catalyst. You see the iron in Haber's process of synthesis of ammonia. In the chlorophyll acts as a catalyst in photosynthesis, like that. So next is surface area of the reactants. More is the surface area, high is the rate of reactions. So how can we increase the surface area? Simply, if we will decrease the size of the particle, smaller the size of the particle, greater will be the surface area, and the reaction will take place at a very faster rate. That's the thing. Next is presence of light. Some reactions are there, they undergo at faster rate in presence of light. Those reactions are called photochemical reactions. For example, hydrogen reacts with chlorine in presence of in presence of UV radiations to form what? HCl. Similarly, methane reacts with chlorine in presence of sunlight to form CH3Cl, that is methyl chloride or chloromethane. This what happens actually, this sunlight or the light energy, they give necessary activation energy for starting of a chemical reactions. That's why the chemical reactions, rate of chemical reactions gradually increases. Clear? So this ends the first part of chemical kinetics. Thank you for watching.